Hi everyone, my name is Nikolai and today I'm gonna install Servo on my milling machine spindle instead this BLDC motor. But first, let's unbox it. I really like those guys. I have all my steppers on my milling machine and lathe from them. Very reliable and nice quality. Also, I got it off AliExpress, but they shipped it from USA anyway, so it can come quickly without any hassle like customs and duties and everything like that. It cost me $166 on sale with coupon that AliExpress does regularly, and also I able to get additional $30 of cashback service, so pretty nice price. Now let's see what's inside. And first what you can see is this paper, which basically tells us parameters of a motor and connectors, pinouts. It says voltage 220, which mean I have to use power converter to power it, and power 1000 watt, 1 kilowatt, and torque 3.18 Newton meters. And there's a graph up to 3000, it's hold torque, and then it starts dropping a little bit up to 6000 RPM, which is pretty cool. The next, what we can see, this box, and what's inside this box is connector to connect inputs and outputs to servo controller, and a couple cables. This cable is probably for encoder, looks like firewire, and looks like it's connect directly to motor, and another cable for connect power to the motor, and you can see the rubber ring around, and this was doesn't have it. The next box will be this one. You can see here another connectors, probably for power and for motor. And in this box we have a servo drive. Servo drive is really nice label. Power connectors, inputs, outputs, encoder. Looks like we can use some software on PC, connect directly to USB Type-C to change parameters. Also buttons and display to change parameters right on servo drive. And RS485 working connectors, which can be used also to change parameters. And last box that remain is probably for stepper motor itself and servo motor. So yeah, as we can see, cables connect directly the brass inserts, and we can see there are no rubber gasket around, and this one has one. That's explain why one cable had and other doesn't. This one is without additional brake because spindle doesn't need it, obviously. And yeah, huge shaft with keyway. Keyway has a hole with thread, so if you want to pull it out, you can thread screw here and it will pulling it out, which is nice. Sometimes it's hard to get out. And another label 220, 1 kilowatt. Now let's talk why I want to replace this BLDC motor with a servo. And as you may see, my milling machine converted to CNC, and I have this, which allows me to change RPM and start spindle, but nothing happens because it's converted from manual milling machine, and to run it I have manually to adjust speed and power it on and then start a program, and I want to avoid it. So servo will allow me to connect directly to my electrical box and to my CNC controller, and I will be able to change speed and enable, disable it directly from GCode, which is pretty nice. And also what Servo could allow me to do is rigid tapping, because we could synchronize rotation of spindle with moving of the z-axis, which is also nice. So now I have to read manual for this servo because it's 360 pages, and figure out how could I connect it to achieve what I want. And when I will done, I briefly explain it, and then we will try it on my milling machine. First we have to connect cables to servo. There are no problem with that, just clip those connectors and screw a couple screws here. Then we have to connect servo to controller. For that there is a connector, and we have to install wires here. To do that, the small little tool, it's just clips here, and then when we press, it depresses lever inside. Probably not visible. So this one V, let's find V. It's this one, black one. So we insert it, press it, and install fully. Now those connectors, those wires connected to connector very firmly. After connecting a motor, which is straightforward, we have to connect power. And since this servo can work at 3-phase, it requires 2 connections from main. So those 2 for logic circuit and those 2 for motor itself. Without second connections it wouldn't work. It would just light up display, allow change settings, but motor would not engage. Beside power, we have to connect all outputs from CNC controller to servo driver. What we need is couple inputs for step, couple inputs for direction. This wire is a digital input 6, which will switch between speed and position mode. And also this input connected to bottom part of optocoupler and through resistor 4.7 kilo ohm. And it's also need a supply voltage, which is gray wire, this one here, that supply 12 volts. It's supposed to be 24 volts, but we'll see if it works with 12. And couple more wires, it's for voltage control to control speed. Basically, that's 8 wires, all what need to connect servo to CNC controller. Next, what we have to do, change some parameters. I wouldn't show all of those, but some will show. For example, C0, it's a group, and when we press here, we now can change which parameter we want change from this group. And parameter 00, it's mode. By default, it's 0, position mode, and we want 3, which is position and speed mode. Save, and it's done. And as you can see, we could rotate it without any problems. And it's because by default it uses input, and this input is not engaged. And since I wouldn't use dedicated input signal, I also have to change group 4, and 11. This is digital input 5, which by default is enable pin, and when you switch it, it immediately start buzzing, and now it's rigid. So I probably will disable it for now. Also, we have to change digital input 6 to mode switch and some other parameters. I wouldn't show all because different servo may have different parameters, and also manufacturer could change default parameters, so you have to go through manual and check all parameters that is there. Now, very noisy bench test. If I do jogging, you can see it moving slowly, but moving. Then if I switch to spindle, enable it, start spinning, I could change speed to 2000, and I could turn it off, and it all works. And then I can jog it again. Now it's time to install it on a milling machine. To install this servo on a milling machine, we need two things. First one, pulley. Original pulley has smaller inner diameter for shaft, and this one slightly bigger, so it have to be replaced. This pulley I did myself, by the way, not the best job, but for test is fine. And a second, we need a mounting bracket like this one on original one, and the problem, it doesn't fit because diameter of this circle is bigger on a servo, but overall dimensions for servo and for BLDC motor are the same. I have no idea why this circle is different. So for now I 3D printed mounting bracket, which will allow us to mount servo and test it. I installed it everything, and as you can hear, it's quite noisy. And now we will try to drill a hole in a plastic with GCode program. First program is simple: start spindle, drill a hole, lift tool up and stop spindle. In the next program, we will use tab to do rigid tapping by synchronizing motion of rotation of a spindle with a linear motion on a z-axis. Result, you can clearly see there's some thread inside. Let's try to screw in M3 machine screw, and yeah, it works perfectly. Screw it in all the way through. Rigid tapping works in plastic, pretty happy about that. But now let's do a final test. Aluminum 6 millimeters width or depth, and 4 different taps: M3, M4, M5 and M6. I already pre-drilled holes, and now let's see what happens. And this is the final result. As you can see, all threads are there. I already tried machine screws in those holes and it works fine. So not any problems. I surprised it's tapped all holes from M3 to M6 without any issues. So it's enough torque to do that, at least in 6mm aluminum, which is pretty nice. In conclusion, do I happy with this modification? Yes, it's more powerful. It's 1 kilowatt versus half a kilowatt. It gives me spindle control. It's also 20% faster. It gives 6,000 RPM instead of 5,000 because my pulley ratio 1:1. But there's one more problem. I couldn't use my pendant with it. And the reason is EMI, electromagnetic interference. Servo was so noisy that it just messed up communication with pendant completely. In next video, I will try to fight this issue. That's it for today. Thanks for watching and see you next time. Bye.